So we all know that there is so much debate going on right now about where computation needs to take place. And here in Davos at the World Economic Forum, this is one of the conversations. We got these diametrically opposed forces right now as compute is dragging so much resource and bringing sustainability back to the forefront, but through a completely different lens. The edge is an opportunity. It's a tremendous opportunity. We bring compute closer. We know how much more efficient that can be. We also know that so many more opportunities can be created if we can bring down the cost of compute and enable greater workloads to be done as close as possible to the compute. So this panel today, we're gonna focus on that. And Osa, I'd like to start with you, and forgive me all, but since we only have about 20 minutes, I'm gonna let his introduction stand. You guys are an absolutely incredible group of people, and I can't wait to hear from you. But Osa, I wanna start with you on part of what makes this possible in the network, okay? We can want to compute out to the edge, but we really need to be able to bring the compute out. So before I talk about some of the applications, opportunities, we can talk a little bit about FSD. I want to talk about how you and Ericsson are thinking about enabling this, because realistically, to get the compute there, the network has become exponentially more important than it was even just 1 or 2 years ago.
Well, thank you, and I'm so happy that someone cares about the importance of the networks. I think it's one of those infrastructure that we all gotten used to. We almost take it for given. And it's actually powering most of our daily life. And when it doesn't work, it's a big annoyance. Now, when we look at AI and automation and much more advanced applications, this is actually why we developed 5G. And that work was started more than 15 years ago. And one part of it was make sure that it could meet the requirement for critical processes, critical operations. If you think about most enterprises, they're not using wireless technology as we do as consumers. So the whole mission was, how can we make sure that we meet the requirements on security, resilience, but also ultra low latency. So when you do machining, they may have a reaction time faster than the human can react. Or if we think about, in many cases for AI applications, you want to not only send data, you want to be able to real time, not only send, but exchange voice or video. And that's why we came up with an architecture. I'm not gonna go too deep on this because you could easily spend the next 20 minutes on it. But it's an architecture where we reinvent how you could say our cellular network are distributed and consumed. So we developed it, part of it is technically that we have an open, distributed, cloud and software-based network architecture. We still have our specifics being in the cellular domain. The other part is really how we're transforming the commercial model so it can actually be consumed and used like any network API. We can get back to that later. But to me, if you think about the transition we're going through now, data and structured data and availability of data and exchange of data to power the meaningful actions and algorithms, if that's at the core or at the edge, for that to happen, connectivity is king.
So Kinuko, I had a couple of very interesting conversations with CEOs over the last few days. I spoke to Chuck Robbins from Cisco, and he was talking to me about how, the opportunity with inference and the exponential size versus training. Because over the last few years, all the focus has been training. It's all been about the buyout of infrastructure for training. And inference right now is only, generating a fraction of the revenue. It was about 10 billion of infrastructure spend on the inference part, where there was like 20 times that or more in training. And then Cristiano Amon said to me that voice is the reason, or at least one of the reasons, he's the CEO of Qualcomm, one of the reasons that the edge will become so important for AI, because there is no acceptance of latency whatsoever. When you're having a conversation in 2 languages at the same time, we will not be accepting a 5 or 7 second delay when you're trying to interact and wait for translation. The work you do focuses very much on an edge application, voice. Talk a little bit about how you're thinking about the edge and how you're thinking about enabling AI versus, kind of the idea that everything can be done in the cloud.
For some of our customers, such as the Department of Homeland Security, the topics that they're discussing is so sensitive that it's very important that the computing is done at the edge. But in other ways, for example, in public safety, also computing at the edge is very important. For example, you can imagine, if we're capturing all the firefighter communication during the LA fires, if we had AI at the edge, we could have notified firefighters when they were in danger because a building was about to collapse. So all these reasons shows how important it is to have AI computing at the edge. But also I want to contradict myself and say that 5G connectivity to the cloud is also important. So we can't forget one for the other, right? Because one of the biggest issues when there's mission critical situations that occur is this problem of inter and intra-agency communication or lack thereof. However, if we had 5G connectivity, we could solve that.
Gill, so often what she just explained becomes the dilemma of this computing continuum. Hybrids won out in many cases, and just like she sort of suggested, the 5G accessibility, yet the local compute is because you really never want to be completely dependent on one. And anybody out there that's even for a minute been without connection, I come here from the US, I bring my carrier, my SIM comes over, I'm walking down the promenade, and I can't get an SMS out. I can't get a text out. We all know how that feels. When you're in a public safety situation, Gill, a critical situation, and you're trying to develop FSD systems, next generation infotainment, where LLMs may come into play, you've got to really think a lot about the mix of where computing takes place to make sure vehicles are always safe, they're always connected, but at the same time, you manage costs and you make sure the data is always fresh. So how are you sort of thinking about that leading Toyota research?
What we try to do is think about things both in space and in time. And for example, in time, we have to make sure that your vehicle is going to be safe, even if it's in some form of automated driving. That could be driving assistance, where it's trying to prevent a blunder that the human being makes from causing a crash, and it's guarding you against doing that. Or it can be actually an application when the car's not even moving. So we're in our cars only 5% of the time. 95% of the time, the car is parked. And it's got this incredible computing resource inside of it these days, and we'll have even bigger ones in the future. Is there any way that we could put that to use? So when we think about connectivity to the cloud, we see it as optional and to be exploited whenever possible, but we have to make sure that it's not something that we critically depend on, so that if for whatever reason it is broken, we can still be safe, but if it's there, we can actually exploit it to be even safer. And this is where the issue of space comes in. So I talked about time, talking about space now. When you're doing automated driving, either as the car is driving for you or it's trying to prevent you from having a blunder cause a crash, you want to see beyond the sensors of your own car. You want to actually be able to use sensors in other cars that are nearby. This is called vehicle-to-vehicle communication. And you want that kind of cloud of vehicles to actually provide your car with a way of being safer than it would be by itself. So that's yet another example of why having this communication, having this kind of cloud of computing is so important.
So I want to pivot a little bit to LLMs and foundation models. And Alexander, I want to talk to you a little bit about this. So another one of these great computational debates is going to be, when you're deciding where the workload goes, you also have to decide how big of a model. There was sort of this early, this science and research loves to do the, quantum supremacy thing. We love to do the biggest parameter LLM thing. But in the real world, at least what our research is finding, is that SLMs, smaller language models, or what I think you're calling liquid foundation models, tend to be able to do specific tasks much, much better. And then in a world where we're heading towards agents, and I'm sure we've heard that word a few times today, the agents will need the right kind of models to do those tasks pervasively. Talk a little bit about how you're thinking at Liquid AI about the models, where the compute takes place, how to make them efficient to be run at the edge, and of course, how does that relation end up working with the cloud, as we've seen inevitably it always has to?
I think one of the interesting things about this panel in particular is that it connects a lot of the previous panels that we've heard throughout the day. In particular, we heard a lot from the owning your own intelligence panel earlier today, and I think that this question really gets at the heart of that panel as well. Right, so at Liquid AI, what we focus on is we build not only small language models, but we build a new type of language model powered by a liquid neural network. These are not transformer-based models, which means that they don't adhere to all of the computational bottlenecks that transformers come with. Transformers are extremely expensive models to both train and run and to deploy. We heard from Jan LeCun earlier today that the hard part of AI is actually deploying the AI, getting it into the real world. And that, I think, is also extremely true. With liquid neural networks, what we've created is a new paradigm for how we can train and deploy these models. And what Gill mentioned earlier is also a really great connection, that it's really, especially in this day and age, being reliant on anything, any AI, any network, is extremely troublesome in some cases. So at Liquid, the benefits of having fully edge-capable LLMs or edge-capable general intelligence is really all about connectivity and all about increasing the scale. We hear a lot about scale of AI systems. People talk about scale, and they're usually talking about the size of the models. But this is only one type of scale. Scale could also mean where those models are, right? So a lot of models, or actually almost all models for AI today, are going up and up on the scale axis in terms of size, but actually going narrower and narrower in terms of where they are deployed. They're being deployed on increasingly large compute clusters in the cloud, and they're getting less and less connected to everyday enterprises, everyday edge devices like cars and robotics and many other types of enterprises. And one thing that what became very relevant for me just recently as I was traveling to Davos was this question of connectivity, because coming from the US, what we really...
Hey, sorry, excuse me. Can we just be a little quieter in the back, please, so the speakers can speak? Thank you.
Thank you. Thank you. Yeah, so I was just going to say one more point, because it was very relevant for me just coming into Davos this past day, because I was coming on the train here, and like was mentioned earlier, the connectivity, even though in today's day and age, it was extremely bad. It was so bad I couldn't even send an SMS message. I couldn't ask a question to an LLM. I was trying to do some work. There's completely no internet connectivity. At Liquid, we've created these language models that fit directly on the phone. They're large general-purpose language models that I was able to pull out on my phone without any internet connectivity, without any reliance on another provider or any internet network to actually access full intelligence at my fingertips. And I think that's actually the definition of owning your own intelligence. It's not only about having an AI that works for you, but having that AI anywhere you go at your disposal.
I want to talk a little bit about the industrial opportunities, Cyril. At Rockwell, I know this is a big focus of the company. I said that IoT almost came too early in some ways. It was very much hyped. There was probably a dome where we just talked about IoT for a few years, and then all of a sudden it went away. But I think it's very much back, and it's kind of under a new mask of edge AI. The opportunity now, whether it's all the way with most sophisticated FSD and robotics, all the way to just things like systems, HVAC, lighting controls that could really help drive the world. I'd love to know kind of at Rockwell how you're thinking about this moment to sort of re-engage. I'm sure you never stopped, but to really re-engage the opportunity to explore the power of connecting everything.
Yeah, so for us at Rockwell Automation, we provide technology, hardware, software, services to people to automate processes, machines, and equipments. And this is an extraordinary moment in our industry of reinvention. When you think about how classically it works, a machine is a programmable construct. Like you program a machine to behave in different way based on different inputs and sensors. You were mentioning IoT. I think the mistake that many made over the last 10 years of IoT is thinking that improvement is just about collecting more data. And it's not necessary, because none of you in this room wants more data. You don't want more SMS, you don't want more information, you don't want more apps. You want things that work autonomously. And this is the way we are reinventing the industry, moving from an automation paradigm to an autonomy paradigm in a very similar way as what we see in the auto industry. So we want machines to autonomously act, react, adapt to the environment, to those information that can be collected through IoT, through connecting everything, to this idea that I think Jan LeCun himself has called sensorymatic AI. The idea is that you sense the environment, but you also act at the end. And all this closed loop of activities happen at the edge. It happened at the edge for a lot of the reasons that have been mentioned by my fellow panelists. It's a problem of performance, even if networks and the quality of networks are improving all the time. It's also a problem of resilience. Like you want critical decisions in your car to happen at the edge. You want critical decisions about a process to happen at the edge as well, because there is people safety implication. There is implication of the criticality on your assets at the same time. And ultimately, when we are able to change this paradigm, there is also the economical efficiency of where do you deploy all this. You have this abundance, even this excess abundance of data in an industrial process. There is no economical good reason to move all those raw data to the cloud. All those data needs to be aggregated, contextualized, associated. Raw data needs to become information, and information consumed by AI, LLMs, SLMs, we work quite a lot on SLMs as well, become insight, and especially actionable insight, which is what makes those machines autonomous. So this is, for me, all the arc of reinvention of our industry, and this really applies very well to the context of our customer in digital application. They want people to be empowered to do better things with their machine, and they want a process that is in autopilot, but with a human in the loop that can, instead of being focused on the physical task or monitoring parameters, can be focused on the outcome of the machine, which is what matters for the business.
So we have a few minutes left, and I'd like to do something where I give each panelist a chance to respond. Over the last 30 days, our firm, Futurum, partnered with Kearney and did a survey where we talked to 213 CEOs of companies with more than $1 billion a year of turnover about their AI implementations, challenges, opportunities. And this group, between researchers, CEOs, business leaders, you are in the thick of it right now. So this event, Davos, is really the moment of inflection for all this infrastructure turning to value. I'd love for you to give this audience a chance to hear a little bit from you about how, whether it's deploying at the edge or just in general with AI, how you're sort of thinking about enabling success within your organizations and for your customers. And Gill, I'm going to start with you. I'm going to have you guys kind of come down the line, and we'll wrap up there.
The most important thing to realize is it's something called Amara's Law. We've actually heard it a couple times in other sessions here, which is that we tend to overestimate the rate of change in the short term, and we tend to underestimate it in the long term. And this happens with every kind of exponential curve, and I think AI is very much like that, but kind of speeded up. So what we are doing is we're looking for every possible way that we can foresee right now for accelerating our efficiency inside the company, but also developing new value and new products outside of the company for customers as well. But we're being very humble in our ability to predict what each one of those are. So we believe that the answer to that kind of uncertainty is diversity. And so we're just trying many, many different things.
Yeah, I think there's so many things that are extremely exciting in today's world about AI. I think one of the things that really motivates us is this notion that today's AI systems are need to go far beyond language only, right? So we've talked a lot about LLMs or SLMs or all of these types of LLMs, but in reality, especially at the edge, all of the power of AI becomes extremely multimodal very, very quickly. Multimodal means that we have to be able to deal with language, with text, with audio, which is completely a different modality than text, with images, with video, and so on. We need the ability to do all of this at the edge. And I just want to mention one thing about when we think about edge, it doesn't necessarily mean we're running on very compute-constrained devices or on network-constrained devices. I think one thing that is extremely motivating is that when we think about what are the reasons why someone might want to deploy AI at the edge, it can be extremely multifaceted. And we can think of these on a few different axes. So number one, we already talked and heard a lot about network, right? Connectivity. This is only one of the axes, though. Another axis is compute and energy. We talked about this as well. You want the ability to run AI, actually, not just to access AI at the edge, but run it at the edge and do so in a very sustainable way. There's also about privacy. So this is where you get outside of the classical form of what it means to be edge, for example, on small devices or small models. We work a lot with also edge in the non-traditional sense as well, where we deploy big models in a very sustainable and effective way into enterprise as well. Perhaps even though they have extremely high connectivity, you still want to own the intelligence and do so at the level of the enterprise itself. And of course, we have the problem also about data transfer as well. It was mentioned previously that it may not always make sense, even though you can move a lot of this data across the network, it may not make sense to do so. So we think about also the necessity to be in some form offline by design of the data and by the use cases. And I think all of these actually really motivates the reason why Edge AI is so multifaceted to scale far beyond LLMs, right? This is extremely multimodal. It's also extremely multifaceted in terms of use cases, right? We've heard a lot about agents and a lot about the new use cases that those will enable as well, especially when we think about having personal agents, the ability to have autonomy over our agents, not only for latency and connectivity and resilience, but in terms of the actual sovereignty of the AI, this becomes extremely important as well.
Yeah, I think we have spoken a lot about technology, and if we go beyond the edge, the cloud, AI, SLM, LLM, I think there are two additional ideas that are important to open the conversation. First, thinking about the business first, as I mentioned, I think it's the power of AI is the power of reinventing the business, about thinking your business in a different way. It's not about applying modern technology to do more efficiently the old recipe. So I think we need to have the mindset to think about the business. And if we think about business, business is about people. And for me, we should not forget that we have the choice as an industry to make AI for people or to make AI against people. And we are at this crossroads, and the year to come is going to put our conviction to the test on that specific topic.